Ladies and gentlemen, we are given a problem that requires us to sketch the following periodic. This is a periodic waveform in time domain and compute its Fourier transform. So we are told this is a periodic signal. So its plot will look like this. You have t here, you have f of t. So you have 2 and you have -2. Then this is 3. So we are told that the signal is 3 between -2 and 2. So it will move like that. And then 0 elsewhere. So if it is 0 elsewhere, then that becomes the waveform of this signal. So that is part 1. So part 2, let's look at its Fourier transform. So f omega, first of all, is equal to integrating from negative infinity to positive infinity of f of t exponential of negative j wt with respect to t. So let us put in the function f of t. So f omega becomes integrating from negative 2 to 2 of f of t, which is 3, times exponential of negative j omega t with respect to t. So this gives us just 3 integrating from -2 to 2 exponential negative j omega t with respect to t. So our Fourier transform becomes, if we integrate that, remember you'll have exponential of negative j omega t out of negative j omega. So we have from -2 to 2. So this gives us exponential 3 into exponential of -2 jw, then minus plus 2 jw. So divided by negative jw or j omega. So f omega becomes now, if I cancel this and that, then the negative comes here. So this becomes 3 into exponential of j2 omega minus exponential of negative j. So minus exponential j2 omega. So divided by j omega. Now from Euler's identity, we know that sine theta, actually 2j sine theta is equal to exponential j theta minus exponential negative j theta. And then, so that means 2j sine, okay, theta is 2 omega, so 2 omega will equal to a exponential j to omega minus exponential negative j to omega. So I just substitute this here, and our Fourier transform will therefore become 3 times 2 times j sine 2 omega divided by what? Divided by j omega. So this and that will go. I'll have 6 sine 2 omega divided by what? Divided by omega. So that becomes the solution, but we can actually go ahead and convert it into a sinc function so that we have f omega equivalent to 6 sine of 2 omega. Then we are going to divide it by 2 omega, then we multiply by 2 here. So this becomes 12 out of, 12 sine 2 omega divided by 2 omega. So this Fourier transform becomes 12 times sinc to omega, because the sinc function, for example, sinc of x is equal to sine of x divided by x. So replace x with the 2 omega, this solution becomes like that. So f omega, which is equal to the Fourier transform of f of t, will become 12 sinc to omega divided by, and actually that is the solution. So you can see we have transformed the Fourier, this equation from time domain to frequency domain, because it was in t and now it is in fw, which is frequency.